Morning everyone. Today we're going to apply the knowledge that we've learnt in the last couple of lessons to now sketch a cubic. So later on I'll show you how long division comes into all of this, but at the moment we're just going to start with this cubic equation here. Y equals x minus 2 multiplied by x plus 3 multiplied by x minus 1. Now if I sketch that on my CAS calculator, this is what I do. First I'm going to define it as f of x, just so I don't have to type that in multiple times. And then if I put this into the graph, it should look something like that. Okay, now we've seen these kinds of things before. We've usually seen this kind of graph, x to the power of 3, just like that. But now this one is the same sort of thing. So the blue one, I'll get rid of this graph. The blue one is still a cubic, but you'll notice how it crosses the x-axis a couple of times and the y-axis just once. So I'm going to put that across over to here in my document, and now what I want to do is I want to explore how I find out the x-intercepts and the y-intercept as well. We could do this with a calculator or by hand. I'm going to do it by hand. Well, I know that the y-intercept is always when x equals 0. So I'm going to put that into my equation, and I'm going to get 0 minus 2 multiplied by 0 plus 3 multiplied by 0 minus 1. Okay, which is simply negative 2 times 3 times negative 1. 2 negatives makes a positive, so I should get the answer of 6. So this point here on my graph should be 0, 6, and it's always as simple as that. Now to get my x-intercepts, I use a little bit of the knowledge that you learnt in your other maths together with the knowledge we've learnt in this maths. So to get my x-intercepts, again, it's always when y equals 0. So I'll now have the equation 0 equals x minus 2, x plus 3, x minus 1. Some of you have already seen where I'm going with this. Now I can use the null factor law, which you learnt in your other maths, to say that if that x minus 2 times x plus 3 times x minus 1 equals 0, then x minus 2 equals 0, x plus 3 equals 0, x minus 1 equals 0. Now just solving those three equations should tell me that x equals 2, x equals negative 3, and x equals 1. If I look up to my graph, that's exactly where all of those points will be. X equals 2, x equals negative 3, and x equals 1. So you can see how now getting a cubic in this kind of formation here is actually really powerful. So now I'm going to show you a couple of other things with cubic graphs. Okay, now I want to show you a couple of different types of cubic graphs, or as I've called it up there, different shapes of cubic graphs. I'm going to look at 3 examples, and you can see the 3 examples there. Each time I'm going to find the x-intercepts, the x-intercepts and the y-intercept. The first one, as you can see, has 3 brackets multiplied by each other. The second example has 1 bracket squared multiplied by another bracket, and the third example just has 1 bracket cubed. So first I'm going to do, I'll do the first one, and I'll do the y-intercept of the first one. Now again, that's when x equals 0, and just for the sake of space, I'm going to do that fairly quickly, and I'm going to say that it's negative 4 multiplied by 1 multiplied by 3, which gives us the answer of negative 12. Now the x-intercepts, again for the sake of space, I'm going to, actually I will do these all throughout. I'll go that x minus 4 equals 0, x plus 1 equals 0, x plus 3 equals 0. So x should equal 4, x equals negative 1, and x equals negative 3. Okay, now I've already done this graph before, so I can have a look at it down here. It's very similar to the first example that we did. There it is there. Now all of these points I can put on now. I can say that this point here is 3, 0. This point here was at 0, negative 12. That point there, negative 1, 0. and this point here, negative 3, 0. I've made a mistake. That should be 4 over there. It should be 4, 0. Okay. Now, we don't actually know how far down this graph goes down here, or how far up this goes up here. That's something that you'll learn later on in year 11 and 12. We can do it using a calculator, which I can show you a bit later, but for this, for what we're doing right now, it actually doesn't matter too much. Okay, as long as the graph kind of looks fairly reasonable, it actually doesn't matter all that much at all. Okay, so in the first example, when there were 3 brackets, the graph crossed the x-axis 3 times. Now I want to have a look at the second example. First, I'm going to do the y-intercept. Again, for the sake of space, I'm going to say that it's, well, this one's a little bit tricky actually. I will do this one out. It's negative 2 squared multiplied by 3, because x equals 0, obviously. Now that is 4 times 3, because it's negative 2 times negative 2 times 3, which is obviously 12. Okay, now the x-intercepts, have a look at this one. I get x minus 2 squared times x plus 3 equals 0. That means that x minus 2 squared equals 0 and x plus 3 equals 0. Now that one is fairly easy. That one just becomes x equals negative 3. The other one is a little bit trickier. If I do the square root of both sides, I get the square root of 0 still being 0. So this becomes x minus 2 equals 0, which means there's only one answer of x equals 2. So I've got my two answers of x equals 2 and x equals negative 3. Unlike the first example where I had three answers. Now, let's just have a look at what this looks like in a graph, and I've already done this nicely for us, so it shouldn't take too long, although it comes out massive every time. Let me just shrink that down. How was your weekend? Hopefully it was okay. Where are we? I can't do two things at once. Can't talk and rearrange. Here we go. Okay, now have a look at this graph. Whereas in the first example, it crossed the x-axis 3 times, this graph only crosses the x-axis 2 times. And I'll show you the two occasions, one here and one here. Now we know that's negative 3. We know this point here is 0, 12. And this point is 2, 0. I can conclude, I can tell you that if you have a squared on the bracket, like we do in this case, if you have a squared, it's called a repeated factor, and I'll write that down, repeated factor, which means rather than crossing the x-axis, it kind of bounces on the x-axis. So in the first example, we had no squareds, they were all linear factors, and they all crossed the x-axis once. So there was 3 x-intercepts crossed it 3 times. In the second example, we had one of the factors was squared, the 2 was squared, which means it's a repeated factor and it bounces on that. So there's really only 2 times where it touches or crosses the x-axis, rather than the first example of 3. Let's have a look at the last example. You can probably see where this is all going. Again, I'll do my y-intercept, and that will be negative 2 cubed, which is negative 8. My x-intercepts are actually even simpler in this case. X minus 2 cubed equals 0. If I get the cubed root of 0, it's still going to be 0. So that means that x will actually equal 2. So I actually only have one intercept. Now we've seen these kinds of graphs before, but I'll just grab one like I've prepared earlier. It's going to come out massive again, so I'm going to have to shrink it down. But we've seen these kinds of graphs before when we were doing our translations and dilations and all those sorts of things. This graph only crosses the x-axis once. Again, I guess it's called a repeated factor. Here it is, I can squish it all down. We know this point down here is 0, negative 8. And this point here is 2, 0. So have a look at our 3 examples. If we have no squares or cubes, if they're all linear, it crosses the x-axis, like we have in the first example. If there's a squared term, it touches the x-axis at that point and crosses on the linear point. If you've got a cubed term, then it only crosses the x-axis at that point and kind of does a little, swivel, or I don't know what to call that. I don't know what the colloquial term is, but the mathematical term for that is called the point of inflection. So I'll put that down, point of inflection, something that you'll get more used to next year.